Very often in science we deal with either very large or very small numbers, and it's helpful to have a convenient means to express them. In these situations we turn to exponential, or also known as scientific notation. For example, the number 1200 could be written as 1.2 times 1,000. And that can be written as 1.2 times 10 times 10 times 10, since 10 times 10 times 10 is equal to 1,000. We take this to be 10 to the third, so this number 1200 can be written as 1.2 times 10 to the third. We can also write numbers that are very small, that are less than 0, using scientific notation. So 0.2 can be written as 2 times 1/10. And that can be written as 2 times 10 to the minus 1 power. As we remember that x to the minus 1 is going to be equal to 1 over x. Similarly, we can write 0.0035 can be written as 3.5 times 1 over 10 times 1 over 10 times 1 over 10, because we've divided by 10 3 times. This would be 10 to the minus 3, so the whole thing can be written as 3.5 times 10 to the minus 3. All of these are numbers that are written in scientific notation. We look a little closer. We see every number written in scientific notation has two parts. It has a coefficient. This is the part in front of the exponential part, and this is a number from 1 up to but not including 10. And the other part is the exponent, the power of 10 to which you multiply your coefficient. I want you to also note here that numbers that are greater than 1 are going to have positive exponents. Numbers that are smaller than 1 are going to have negative exponents. Now, the numerical value of the exponent is going to be equivalent to the number of spaces that the decimal point has moved. For example, if we look at the number 1200, we know the decimal point is there. The decimal point has been moved 3 spaces to get 1200 to a value between 1 and 10. The positive exponent indicates that the number decimal equivalent is greater than 1. For 0.2, we see the decimal point has been moved 1 space. That's where we get the 1. And again, the negative exponent indicates that this number is less than 1. 0.0035, we see the decimal point has been moved 3 spaces in order to get to a value between 1 and 10. That's where we get the 3. And again, the exponent is negative, indicating that the decimal equivalent of this number is less than 1. Let's practice a few of these conversions between scientific and decimal notation. Okay, first we see here we'll have to move the decimal place 1, 2, 3 spaces to get to a number between 1 and 10. So we can write this number 2.100. We need to include those trailing zeros because they are significant. We get the value of the exponent from the number of times we've moved the decimal place, 3 times, and we know that it has to be a negative 3 because this value, the decimal number, is less than 1. Here we have to move the decimal 1, 2, 3 spaces to get to a number between 1 and 10. So we write all of those digits in that coefficient, and then we're going to have a power of 10. The power of 10 here is going to be 3, but it's a positive 3 because this number is greater than 1. All right, so let's go the other direction. First, we see here that this exponent is negative. That means this value, the decimal equivalent of this value, is less than 0. So we're going to have to move the decimal point in this direction, and we'll have to move it 2 spaces. So we have 0.0600 as our decimal equivalent. Note we preserve our sig figs. We have to keep these trailing zeros, and we've moved the decimal place 2 spaces. Again, this number is less than 0 because this coefficient is negative. Here we see our exponent is positive, meaning this number, the decimal equivalent of this number, is going to be greater than 1. We're going to be moving the decimal point in this direction so that we can get a decimal equivalent greater than 1. So we're going to move it 2 spaces. Now remember, we have to preserve our sig figs. So we move the decimal point, and we have to make sure we keep those trailing zeros. Our decimal equivalent is 520.0. Again, we have to make sure that the number of sig figs match. Here's a useful hint. Whenever there is a number written in scientific notation, all of these digits in the coefficient are going to be significant. So we see here we have a number with 4 sig figs. We have a number written in scientific notation where the coefficient has 4 sig figs. This has 6. This has 6 digits in that coefficient. 3 digits in the coefficient of this number in scientific notation. So our decimal equivalent number has 3 sig figs. Similarly, 4 digits, 4 sig figs.